Okay, so today we're going to talk about grading assignments using a rubric. And before we do that, I just want to reiterate that there are two common elements to the purpose of grading. And the first is the obvious one, assessment, evaluating a student's learning and making sure that they are meeting the course objectives and measuring the degree to which they're meeting those course objectives. But equally important for us in this course is the ability for us to give students corrective and improvement-focused feedback. And in order to do this, we want to acknowledge the students' efforts. We want to foster their learning of the course concepts and develop their ability to apply those concepts. And we want to take the opportunity to encourage them to continue in this course. So the goals of grading are three primary goals. We want the grading to be timely, specific, and improvement-focused. The timely feedback promotes the understanding and allows the student to adjust and improve before the next assignment is due. Being specific, the feedback should be specific. It shouldn't be just a grade, a numeric grade, or a letter grade. It should help the student understand in what areas they're succeeding and in what areas they need to focus in order to improve. Any deduction in points should be explained in terms of what specific criteria were not met and how specifically the student can meet that criteria. And the grading should be improvement focused. It's not enough to just simply assign a numeric score to a student's assignments, and it's not enough to just list the errors that the student made and provide correct answers for those. We should take the opportunity to mentor the student and to support their learning process. Whether the student scores a C or a B or an A or even 100%, or they score a D or even an E, we should support and foster each student's growth and higher success. All students can improve, and as graders and instructors, it's our job to promote that growth and success. So the first thing you should take a look at when you're going to grade an assignment is the assignment instructions. This is where students are going to start, and this is where we should start as well. In order to grade well, we'll need a clear understanding of exactly what the students are being asked to do. Read through the instructions more than once, preferably. It's also a great idea and often worth the time and effort to actually do the assignment yourself. It shouldn't take you terribly long, nowhere near as long as it's going to take these students who are just learning programming for the first time. There's no better way to get a good sense of where the students are likely to struggle and why than to read through the assignment instructions. Now, the grading rubrics have two components. There's the criteria and then the standards to be met for each of the criterion. And then there's the purpose of the rubrics. And the reason we use rubrics for grading is it promotes accuracy, consistency, and efficiency. So let's talk a little bit about the criteria. The criteria are the properties or the characteristics on which the assessment or the assignment will be evaluated. And the standards are the level of performance that the student should achieve on each criterion and points associated with those. The accuracy component is there for both the students, because the students get to see these grading rubrics before they start the assignment, and for us as graders. They tell the students what concepts to focus on and apply, and they tell us as graders what concepts to focus on for the assessment. Consistency. This is where a rubric helps to ensure that students' scores are consistent for similar work quality. There's always a subjective component to grading. A rubric helps to minimize that subjective component. And then there's an efficiency component. It makes our jobs easier as graders by helping us to focus on just what we need to assess and reducing but not eliminating the subjective element of evaluating the student's work. So here's an example of the first two rows of a grading rubric, and you'll see the criteria on this first column, and for each criterion there's a set of standards or a standard to which the student's work meets this criterion associated with a set of points. And you'll have this for each assignment that you grade. And it's really important to follow the rubric when grading. This means that we should not base any part of the student's score for this assignment on any criteria that's not explicitly included in the rubric. And this also means that we should strictly follow the standards when we're awarding points for the criterion. Most of the assignments also have a document that includes a common feedback template. It's also broken down by the same criteria that you'll find in the rubric and the standards for each of those criteria. And for these standards, various standards, there's kind of template feedback on what you might say to the student who scored a minimal standard on the criterion of documenting the 6 problem-solving steps. These are intended to be guides in helping you provide consistent feedback that'll help the student improve. Occasionally, you might actually simply copy and paste one of these and submit that as part of your feedback to the student, but more likely you'll use this as a template, a starting point to craft a more useful and targeted specific comment for the student's continued success and growth on that particular criterion. So let's take a look at grading an actual assignment using a rubric. And the assignment that we're going to look at is an assignment from weeks 9 and 10 of the course, where we're just starting to make the transition from Python to Java. This is the design review assignment for the algebra tutor problem. And of course, the first place you should start is you should read through these instructions yourself. These design reviews are intended to get the students to think about the problem they're trying to solve and start to sketch a solution without getting bogged down in the details of a particular programming language or particular programming concepts, and then slowly working their way through to those more detailed concepts and how they might apply them in a given language like Python or Java. So here's the set of steps for them to follow. They need to define the problem, outline a solution, create a structure summary. Here's an example of what they should post. Here's an example for them to review, so we can open this and take a look and get an idea for what the student's submission should look like. So this would be a design review for Pearl's pancake pad, defining the problem. Here's a problem description. You know, it's a statement, a sentence or so. A list of the inputs to the program, a list of the expected outputs from the program, an outline of their solution with a little bit of stepwise refinement, a rough draft and a more refined draft, a structure summary in which they list their expected use of functions, maybe some names for those functions, parameters and return values, a list of where they expect to use decision logic structures and looping logic structures, and then finally a list of questions that they have that they haven't answered yet, or that they're concerned that they might struggle with in this assignment. So this is an idea, and this gives the student an idea of what they might be expected to turn in. And then of course the details are in here. And we should read through this and make sure that we have a pretty good understanding of what's being asked of the students. And this particular assignment, the due date has passed, so we can scroll down here and you'll see the first submission area, which is for the audit students, and then you'll see the second submission area, which is for the ID verified students, which is where we're going to want to go. And if I click here, it'll check out the next available submission for me to grade, but I can also click here and view the current statistics, and I can see that there are 20 assignments waiting to be graded. None of them have been graded yet. So I'm going to go in here and I'm going to click on grade available responses. There are 20 available. And here's the first one. Here's the student's submission. I'll click on this. It opens in a new tab. This is a PDF that the student submitted. I'm just going to take a quick look. It feels a little light to me, but... And then, of course, below that, we see the rubric embedded in edX here, which makes grading a little easier for us. So we can focus on these specific criteria and determine to which standard the student meets that criteria, and we can provide some comments along the way. So the first criterion, and I've got the rubric up over here as well, and that's going to make it a little easier for me to review this. So the first criterion is define the problem. And the standards are, the design includes a clearly written and complete high-level description. So is this a clearly written and complete high-level description of the problem? A math teacher is looking for a new way of helping kids study for a midterm. He wants to have an app that allows them to study easier. That's where we come in and making the code for the app. Let's see if it doesn't feel quite like clearly written and complete high level. So let's see what this next standard is. Design includes a clearly written and mostly complete high level description. That's closer. Design includes a mostly complete, maybe it's not clearly written, high-level description. So on this one, I feel like this is a 6. And I'm going to go ahead and go back here, and that is the 6 is fair, and so I'm going to select fair here. The design includes a mostly complete high-level description. And I might copy this and come in here and say something like this. Your description is a great start. However, it is a good idea to be a little more detailed at this stage. This will help you when you get to the point of designing your solution. And then I'm going to go on to the next criterion, the outline the solution. So for an excellent on outlining the solution, we want to see that the design includes a rough draft and a highly refined outline. So let's look at the outline. Rough draft. Which mode would you like to study in? Random int. These are 3 modes. Solve for the value of y, solve for the value of m, solve for the value of b. Here's the refinement, not available. Okay, so he's got a rough outline and no refinement. So let's see where this falls on the rubric. So it's not excellent. Design includes a rough draft outline and a mostly refined. Design includes a rough draft outline and a partially refined. Design includes a rough draft outline. Design does include a rough draft outline. The last one is there's no outline to evaluate. Well, this is not true. So in this case, we've got a 4 minimal. So I'll go back and mark minimal here. And here I probably want to provide some more constructive feedback. I will say your rough draft can be even simpler than the one you created. Then you can add detail to this to create a more refined outline. Continue this process of adding detail until you feel that the outline is fully specified. And you are ready to implement it. And then we'll take a look at the structure summary. So the structure summary, in order to score excellent, the structure summary includes a description of at least 4 structures: functions, decisions, loops, with at least 1 function, 1 decision, and 1 loop. All right, let's take a look and see if they have a structure summary. Here's their structure summary. Functions, list of functions with name, parameters, study mode 1, study mode 2, study mode 3, a quit function, a random int function, an overall score function. Some of these don't feel like functions. Study mode 1 doesn't quite feel like a function. It feels more like possibly a variable or a value for a variable. Quit could be a function to generate a random int. That seems reasonable. Maybe a function to compute the overall score or retrieve the overall score. We have a section here on decisions, list of decisions. In this moment, I've not thought of any if statements. I seem to figure that stuff out as I'm going along in my code. Now that's an interesting comment. Loops, list of looping logic structures. A loop for the whole study mode until the user wishes to quit. Excellent. A loop for each of the study modes. Right? Okay. Well, let's see here. So the structure summary. At least 4 structures. He's got several functions. No decisions, and a couple of loops. I'll go ahead and say that between these 3 plausible functions and these 2 good loops, that meets the 4 standard. With at least 1 function and 1 decision and 1 loop. There are no decisions. So at least 3 structures with 1 function, 1 decision, and loop. There's not 1 decision. Structure summary includes a description, at least 2 different structures. All right, so this is the standard met. We didn't meet the good standard because there is not at least 1 decision structure detailed in here. But there are at least 2 different structures. So I'm going to score the student a fair on this criteria. And then I'm going to put together some comments. I'm going to say your structure summary is also a good start. Some of the items you listed as possible functions do not seem like functions to me. For example, study mode 1, etc. these are more likely variables or a value for a variable. And then I think I'll challenge the student here. Surely your code will need to make decisions. For example, when the user selects a mode like study mode 1, and then I'm going to say, you did a great job of identifying uses for loop structures. And then I'm going to move on to the next criterion, open questions. So this one is, they were asked to provide some questions that they still have, and told that if they couldn't come up with questions, then they should just make them up. So there should be some questions here. So this one seems to be the hardest one to map out what I would like to have as a base for my code. I think they're referring to this particular assignment, the algebra tutor, and they're right. This is the most challenging assignment they've encountered so far. Any tips on how I can better myself to complete this task? So they have 2 questions listed here. So let's see where this falls. Well, this one's pretty easy. Submission includes at least 2 open questions. That's another fair. So I'm going to go ahead and select fair here, and I'm going to say, it is obvious from your comments, and maybe I can quote one here. From your comment, that you have more questions than you asked. And I'm going to say, don't be afraid to ask lots of questions. And I'm going to say, very often, just coming up with and asking questions can be very helpful part of the process. And then there's design quality. The design is complete, detailed, and very likely to solve the given problem. I don't think their design is complete and detailed. The design is complete but missing some details and mostly solves the given problem. The design is incomplete, missing details, and partially solves the problem. I feel that the standard met here is this standard of fair. So I'm going to go ahead and score them a fair on design quality and say, I always recommend spending as much time as possible on this design aspect of programming. It tends to pay off very well when it comes time to implement the solution. And I'm going to say keep up the struggle. And then I could put an optional comment down here if I wanted to say anything other. And I think I'll put a comment down here. I'll say, overall, I think you have a great start here. As you gain more practice with this kind of focus on design, I think it will begin to feel more natural and become a very valuable part of your problem-solving process. And then, of course, I can click here to submit the assessment, and that will take me out of this grading session, or I can click here to submit the assessment, and it will immediately check out the next student submission for me to grade. But for the purposes of this video, I'm going to go ahead and click here and close down this grading session for now. You'll see there are still 19 available. There were 20 and none others are checked out. So I hope you find this a useful tutorial. Don't hesitate to rewatch this a couple of times. And this is really our best chance to help these students in a meaningful way.